I'm from Deloitte. We're in the Deloitte digital floor here. It's, well, hopefully not quite as corporate as you were expecting. But it's, yeah, we're still quite corporate. But yeah, we've got an Android practice. Well, we've got a mobile practice. Our Android practice is a little bit less mature than our iOS one, mostly because we haven't had clients and work until about 4 or 5 years ago. So we have been growing the Android side of things, and we are continuing to grow. So if you know people or you yourselves are looking to come and help us, we would be very excited to have you. So yeah, cool. Anything else you want to say on that, Ollie? No? All right, cool. Okay, well, I will get on with my talk then. I've never done a talk before, and I've never been to one of these things before, so please go easy on me. We'll see. Hopefully, it'll go well. Right, I'm going to talk about encrypting data on Android. Hopefully, it's not going to get too intense, but just shout if it's getting too much, or if it's just not really enough. You know, if it's really trivial, then probably keep that to yourself. I think. Okay, so encrypting data. Why should we encrypt data? I hope that for everyone that is reasonably obvious. What have I said here? Obviously, we want to encrypt sensitive data, and the baddies can't read it. And maybe my favorite ever meme, Frodo there, about keeping his secrets. So the idea of encryption is very simple, and it's been around for a very, very long time. We have some data, and we want to scramble it up in a way that only we know how to unscramble it. And generally, how we do that is with a key. So we get the data, scramble it up with this key. We keep the key very, very safe and secret. And then we can read the data again, and no one else can if we have our key. So hopefully that's not news to people. If it is, then welcome along. Okay, so what are the options on Android at the moment? I've been working on the encryption, or some of the encryption stuff on the things we've been working on for the last sort of 4 years. Not solely on that, but 4 years ago, and I had a lot less experience. And so we sort of started looking at shared preferences. You know, we just want the things we're putting in there, the key value pairs. We just wanted to make sure that the data that was in there was encrypted. Okay, cool. And I think 4 years ago, encrypted shared preferences didn't exist. I can't. Does anyone know when they brought that out? I didn't check, but anyway, I mean, at some point, Google was like, this would be a useful thing for people to have, is an encrypted version of this shared preferences. And we actually didn't use that for reasons I'll come on to later. But great, good to know that Google and Android want us to use encrypted shared preferences and make it fairly easy for us to sort of use it out of the box. You know, you can basically define a pretty simple key, pass it in, and it kind of does most of the legwork for you, which is nice. And there was some documentation on it. Cool. I went to that documentation in writing this thing and realized it had been deprecated. I don't know when. Does anyone know when? I'm sure. Yeah, like a while ago, right? Last year, okay, maybe like a year ago. Okay, well, I didn't know that. We weren't using it, so, okay. But it just says, okay, this class is deprecated, go to shared preferences. Fine. Okay, so we go to shared preferences. It doesn't mention encryption anywhere on the shared preferences page. Okay, that's helpful, thanks. It also has a note on here saying, actually, don't use this. Use the new Jetpack data store, which I also haven't really got much experience using, and I knew about it, but I haven't actually used it. I guess it's just a reskin of shared preferences with some thread-safe things and so forth. Yeah, I haven't spent lots of time using it, so I'm sure that plenty of you have. Okay, great. So let's go and have a look at. Oh, that also doesn't mention encryption anywhere. So I don't know. I feel like Google kind of just pulled the rug a little bit there. Maybe they'll bring it at some point. Okay, there we go. So at some point, we are going to get some encrypted data store. Spoilers, yeah. But that's great. I don't know why Google would deprecate something before they've got the next thing ready, but fine. So that was a little aside. But yes, you could use data store, and you could use something like Tink, the Google crypto library. And you know, you can kind of just roll your own encryption on top of data store. So you know, you just encrypt the data yourself, put it in, pull it out, decrypt it yourself. Which, you know, I mean, it's actually not that complicated. So perhaps you know, Google don't need to put too much effort in. But yeah, it would be nice. It will be nice by the sounds of it. Yeah. Yeah. So I guess this thing that you can roll your own, they will kind of and I think people were doing this a lot before with shared preferences. Hence why they built the encrypted shared preferences. Is a lot of people used to encrypt the data manually and put it in and put it out and decrypt it. And so yeah, and then yeah, what am I saying here? Yeah, this is probably how you would do it now if you were rolling your own. I think this would be what I'd recommend. Obviously, I'm talking about encrypting key value pairs, or well, the value specifically. That I'm not really talking about encrypting full databases here, although obviously you can do that with something like SQL Cipher, perhaps. I'm not going to go too much into encrypting databases today, or talk about SQL Cipher. But the principle's still the same. But yes, I've said I'm not going to go too in depth there. So, Android Key Store. Are people familiar with the Android Key Store? People have used it a bit. Some nods. Yeah. Okay. So the Android Key Store. It's been around for a while, and it essentially allows us to delegate some of the management and storage of encryption keys to Android, to the operating system, and not have to manage it ourselves in our in-memory code with just a simple Java library. This is great, and the key store is pretty good. And I think, what am I saying here? Yeah, so it allows us to make use of authentication requirements. So we can stipulate that a user must be authenticated to use a given key. So that's helpful, and the operating system can put that sort of requirement on the key that it creates. And we can also specify that it should be hardware backed. And a lot of Android devices, I think pretty much, I don't know if it's all, I mean, there's obviously thousands of different devices, but most devices post API 28, I think, have some form of hardware backed in like key generation and encryption, which is just a physically separate part of the chip that manages, key store operations, basically, which is very helpful. And it makes it much, much more difficult for attackers to pull the key out. And we, the actual, our application process never actually gets access to, the private parts of the key. We just delegate that to the key store, and it's on a separate piece of silicon, separate hardware. So it's nice for security, and it puts a nice air gap between us and our keys, which is obviously always good. So the key store is good. Right. So the process that I sort of described before that you might use, that encrypted shared preferences would use, and that something if you probably rolled your own on top of data store and with Tink, would be something like this. Authentication and symmetric encryption. So this is kind of what I described earlier. I was going to try and do the mouse with this, but that's dangerous. So we're not going to, I'm just going to point. You're taking your plain text, you're encrypting it, and it becomes some sort of encrypted text that no one can read unless they have this secret key, and you can decrypt it and get your plain text back out. Pretty straightforward symmetric encryption. The same key is used to encrypt and decrypt the data. This is great, and a lot of this is how a lot of encryption works. It's quite simple, and there's lots of widely used and well understood algorithms that do this for us, and the community back. So on the project we were working on and our requirements, we had a few things that meant symmetric encryption was probably not going to work for us. So I'll just run through our requirements. We needed hardware-backed encryption keys, i.e. we wanted extremely secure keys, as secure as possible. So key store was going to do that for us. We were talking about storing simple key value data. So hence I'm not going to be talking too much about encrypting databases, although we do that, but for other more complex data. In this case, it was, we were just looking how can we secure key value pairs, quite simple data. The other thing is that the value is sometimes reasonably large, basically like access tokens, JOTs, things like that, which can be quite big. So that was a consideration. And then the data was going to be being updated fairly regularly. It wasn't set and forget data. It was data that probably was going to update perhaps, most times the user enters the app, right? And then finally, I guess it leads on from that last point, is that we needed to have authentication to read the data, to decrypt it, and we needed to not have authentication to save the data. So as the user comes in and the data changes, we don't want to be prompting them for authentication all the time when we're just saving the data. It might be happening in the background. But when we read the data, we want to make sure that at that point, the user is required to authenticate. So those are our requirements. And so the last point there means that this doesn't really work, because if we have a key here that to use it, we must be authenticated, you can't encrypt stuff without needing to prompt the user for authentication. So a different solution was needed. This is asymmetric encryption. Also, I'm sure plenty of you have also seen this, but if you haven't, asymmetric encryption is basically just using a key pair rather than a single key to do the encryption. So in this case, we've got a little key pair here, public-private key pair. Again, they get used all over the place. Perhaps more often in signing and verifying and inter-party communication, but you can also use them to encrypt. So in this case, we can use the public key for the encryption, and we don't need to be authenticated to use the public key. Anyone can see that. But to decrypt the data, we must use the secret key, and only we can get that, and the user must authenticate to use that. Great. So I think this solves our problem. So with that in mind, we kind of built this secure store, which, as I said here, is essentially a roll our own encryption layer just on top of shared preferences. And the reason we needed to roll our own is because the encrypted shared preferences did not support asymmetric encryption. I don't believe, but please come talk to me later. Don't interrupt me now, but please, please come and talk to me later and tell me I'm completely wrong. But shared preferences, encrypted shared preferences did not support asymmetric encryption. So that's fine. We could roll it ourselves. And so we built this secure store, which encapsulated the sort of management and generation of the keys. It allowed our consumers, so like when we instantiated a version of our secure store, each instance of it, you could decide if you needed it to have user authentication or not. I said here we ended up calling a lot of these the open secure stores. So it's still encrypting the data and decrypting it on the way out, but user authentication just wasn't required on the keys. So we use them for data that we deemed not to be quite so sensitive, but we still wanted to encrypt it, but we just didn't require the user authentication there. It also wrapped up the user authentication prompt. So when a consumer would say retrieve this data, it would handle making the actual biometric prompt to authenticate the user, and then hand back the result, and it would wrap all that up nicely in one package. I said just here at the bottom, we were forced to use an RSA key pair. It seems KeyStore didn't or doesn't. Again, correct me later, please. Not in front of everyone. The KeyStore at the time did not support using something other than an RSA key to encrypt data. Don't worry too much about what an RSA key is. I will explain a little bit more later if that's a little bit complicated. But it's just a type of key pair, basically. We would have preferred to be able to use an EC key pair, but it didn't seem to support this. You can use an EC key pair on KeyStore, but it only allows for signing and verifying of things. So, great. So we've got our solution. And we built this, and it worked pretty well initially. So, yeah, initially, like I said, it worked pretty well for us. And as I said before, we used this RSA key, which is quite intense, or could be quite intensive to generate, certainly on older devices. So we had to just make sure it was done in a thread-safe way that meant it didn't block the user when it was generating the key. Otherwise, the device would hang when the user first loaded the app, which was not a great experience. And our app was a lot of first-time users, so yeah, we spent a bit of time on that. But anyway, so it did kind of work for us. We did then run into some issues, and as I said, we kind of mitigated the RSA key generation time. We reduced our key size. I think initially it was at 496 bits, or maybe 3. I can't remember, but it was larger than that, and so we reduced the size, still within an acceptable range, and that helped. And we, like I said, did a few things to make sure it was running, not on the main thread and things like that. We also found that using an RSA key pair restricted the size of the thing that we could encrypt. So it was fine, and I can't remember what it was, but the first couple of things that we used it for were quite small. They were just sort of simple strings or something quite small, and it worked okay. And we had a larger RSA key. Like I said, I think it was 4,000 bits something, which meant you can encrypt. The size of the thing you can encrypt is linearly scales with the size of the RSA key, and the size of the RSA key it gets more and more and more difficult to use it and generate it. So we kind of ran into some issues where we couldn't encrypt large things like JOTs. So we kind of had to go a little bit back to the drawing board. I would caveat that it was at this point, and this was a few years ago, and I was a lot less. I was going to say I was a lot less experienced than I am now. I don't think I'm very experienced now, but but certainly I was less then. And yes, it was at that point that the iOS side of things looked really quite nice. It just seemed to work for them. They could just say, save this thing and use a key that needs authentication. The operating system handled doing the authentication prompt for them. They didn't have to roll that themselves. It seemed to be able to just, I think under the hood it is using some sort of EC key, so it was able to save large, files straight away, no issues. So that was fun, trying to explain to product people why the size of our key was having an issue and that it was only on Android. And yeah, that was a time that I looked longingly over the aisle and thought, maybe iOS is the one. But anyway, obviously I'm still here, so that didn't happen. So there is a solution to this. It's called hybrid encryption. Is this familiar for lots of people? Maybe, yeah, a few hands, maybe less so than the original, back the first slide when we just had one key and it was nice to encrypt. Yeah, we're not there anymore. Now we are using a symmetric key, which is basically the same type of key that was in the first slide, and a public key pair that is the same kind of the RSA key that we were using before, and we use them together. And I mean, this diagrams, I didn't make this. This is straight off Google, so I'm not claiming credit, but it is very good, I think. Essentially, what you're doing is taking your data that you've got, you encrypt it with a symmetric key, which you can encrypt any size of data. I won't get into the maths of it, but because I don't know. But yeah, you can encrypt any size of data with your symmetric key here. So we encrypt our data. Brilliant. It's encrypted, but it's encrypted with this symmetric key, which what if we want to enforce that the user needs to be authenticated to use this key? And we need to be able to use this key here and here. So this key doesn't require user authentication, okay? But it will encrypt our data. Great. Then we can use our public-private key pair that does require the user to have authentication to use it, but not the public bit. So the public bit can then encrypt our key that we've just used to encrypt our data, and then put that encrypted key next to our data. So we store those two together in a nice little payload or a little blob. And then when we need to get it out again, we first take off the encrypted key and authenticate the user, and then they can use this private key and get that out. And then they can use that to decrypt the cipher, the encrypted data that we want out. It's a little bit long-winded, but again, this is great, and it seems to solve our problem. And I think I'm trying to. Let's see where I'm at next. Yeah. So, and that does basically solve our problem, and that is basically what we landed on. There's some nuance. This bit lives in the key store. This bit doesn't, but we generate a new one of these for every piece of data. This one is ephemeral. This one's ephemeral. This one lives for the length of time of the secure store instance. So when you generate a new instance of secure store, it will generate this public-private key pair, and it will use those to encrypt all the bits of data that come in. But for each bit of data that comes in, we will generate a new symmetric key. And they're very easy, AES 256, perhaps people have seen this before, I don't know, maybe. It's very quick, it's very efficient, it's very well understood, and that's the symmetric key, that is. It's easy for us to generate these and store them. They're not very big, they're very efficient. So we like this, and this worked. Hurrah. The next thing was making sure that the user authentication layer that sat on top of that encryption, decryption stuff worked for us. So there was a couple of things to consider here. There's a thing called timeout when you build your key. So when you generate your key on the key store, you have to provide it with a timeout. And that basically just means how long since the user authenticated can you use this key? Maybe it's a minute, maybe it's 5 minutes, maybe it's like 1 second. So there's the timeout, and we had to consider that a little bit, and that is basically when, how often and when do we need to do the user authentication. And then the other thing is just what level of authentication do we need to prompt for? We'll come on to that. So the key timeout. We could make this quite short, i.e., ideally this would be as short as possible. That's the most secure, is as short as possible. So that's what we were keen to aim for, basically. You can set it to 0, and maybe some people know this, but if you set it to 0, it actually links a specific user authentication to a specific use of the key. and you actually provide the cipher, which includes the key, to your authentication code, it authenticates the user and it says, you may now use this key, and you can use it once, and once you've used it, it's locked away again. That's like the most secure way of doing it. So we did consider this. So I said here, based on the above, we must talk to our product folks. Scary. And trying to explain to them these technical limitations. I can see my product folk over here in the white. And I'm very lucky because he's very good and he's very tech. But I'm sure some of you may not be so lucky as to have their own Hamish. But I was very lucky. We were very lucky. And so we had a lovely chat. And we had to make them understand that there must be a decision made here. How often do you need to access the data? And what data do you need to access? And when do you need to access it? Ideally, we can set this to 0, and you can access the data, like whenever you need to access data, sorry, you must authenticate the user. Okay, that seems simple. But then what if we want to access the data midway through this journey? Or what if we need to access data, check something else, then access some different data based on that? Okay. Well, then you have to authenticate the user every single time. And I don't know, I mean, it's not an issue for me, but Hamish wasn't very happy about that. So, that got vetoed. And we had to decide, really, you could either bundle the data up into a big blob and get it all out once, or at least bundle it into blobs that you could get out what you needed at the time to make sure that the user's not just constantly scanning their face or their thumb or whatever it is. Or we split out the data into sort of smaller parts, like as you normally would with your key value. You're storing maybe 4 or 5 different things, and set the timeout to something small, like 2 seconds or 3 seconds or something like that. Spoiler, that's what we did. We split the data out here, and the timeout was a few seconds. And it fit much better with our product, and the risk is still very small. I mean, security, and obviously this is mostly about security, is always layers and layers and layers. It's not on or off. So you're just adding more and more and more layers. But at some point, the product folk weigh in and say, someone actually has to use this product. And so you have to make some considerations for that. So we did. We split the data out into smaller pieces, and the timeout basically was set to be very small, or as small as feasibly possible. Yes, I have a note on the bottom of both of these. Does anyone who runs an app that supports back to API 29? Probably quite a lot. Okay. Not so many, just us. No, well, if you do, then yeah, it's a little bit painful, and it's certainly painful with this. Quite a lot of the APIs around user authentication. Have I just, no, sorry. Quite a lot of this stuff to do with user authentication changed quite a bit in API 29, or like post API 29, API 30, I guess. And it meant that, for example, if you run through the key store and you look at API 29, it doesn't let you set the timeout in the same way. And on the next slide, I'm here talking about setting the authentication levels. This is a screenshot off of the Google documentation, but on devices you have 4 levels of, well, 4 different types, I suppose, of biometrics or device credential. The device credential is just the passcode, like the PIN, passcode, whatever. I don't really know exactly what fits into these, but it will be things like most Samsungs, or so now they're getting better, but certainly previously you had phones which would do face unlock, but that was not deemed to be biometric strong class 3. And I think it's still the case. I think it's just Pixels where the face unlock actually reaches this level. Most of them you are still sitting in here. I think the Samsung Iris scan, did anyone do that before? a bit crap. No, it didn't really work. But I actually think that that was a higher level. But there is documentation somewhere about like all the devices and what where they rank here. But it obviously is quite difficult for Android, Google. You've got to give them that there's literally like thousands and thousands of devices, so they can't really keep up. Not like Apple. They don't have the same sort of control. So anyway, you can see here on these last columns that it mentions specifically that key store time-based keys, and this, my screen wasn't wide enough. I don't know what that says. Something else to do with the key store. I think it just says operations. You can't use convenience or weak biometrics. It doesn't allow you. You have to use biometric strong or device credential. Which it deems to be the sort of same level. You can see they're the same. They just have yes on all of them. Which means, we had to. You have to stipulate that when you do your biometric prompt. You have to tell it. I want it to be at least this level, and so it will force it to prompt for like a fingerprint, for example. Like pretty much all the devices, the fingerprint is the thing that's class 3. So it will prompt that, and we have to do that to comply with the key store stuff. But as I said, little caveat, API 29, well, Bianca at the back there spent a long time researching this, uses a slightly different way of building biometric prompts. And it's very, very painful because it doesn't perfectly map or perfectly translate into these things here. And that then also doesn't necessarily translate to the keys that you've put in the key store. And I guess Google maybe could have done a little bit of a better job there. But maybe I've bashed Google too much in this. I'm sorry. Cool. Another fantastic Lord of the Rings meme. So not only is it secret, it's now safe as well behind authentication. Some closing thoughts. So we've been running this sort of solution that we have in production for a long time now, 3 years. And it has been good. It has worked well. We've had pen tests, plenty of them, and they've not had any issue with it. It's been in production. We haven't had any issues. Lots of people have looked at it. Lots of people have reviewed it. So if you have ideas, then please come and talk to me because we want to hear them. But we're pretty happy with the solution. We don't see that many. So in Crashlytics, we don't see that many errors from the actual key store in production. Most of the errors come from the biometric prompt and managing the complication with people cancelling it or not. There's so many different devices trying to manage whether they've got the right level and things like this. So that's quite complicated. But the actual key store stuff's pretty good. I would say, and I'm sure this goes without saying, but that if you are making changes or refactoring or doing anything to this kind of code in your apps, take your time. Take your time. Get some space, get lots of people to look at it and review it, discuss it a lot. Don't rush into this stuff and make sure you've got, migration strategies. Because if you change stuff to do with your keys and then you update, it's not going to be able to use the old keys. So just be really, really careful. And then you'll be fine, I'm sure. We have been, sort of. All right. And then myself, I was just saying here, I've like I said, when we started doing this, Chris, 4 years ago, maybe 5 years, a while that we started on this. I knew even less than I do now, and I'm fascinated. I love the cryptography stuff. I think it's really cool. I've always been quite interested in it, and so it's been really cool, really fun to be able to work on this kind of thing at scale. Not too many people get the opportunity to build stuff and encrypt data and see it happening in real time and have hundreds and hundreds of thousands of people use the stuff that you've written and it seemingly work. So that's really cool. And for people who I don't know if there are, but if there's anyone who's found some of this stuff like a bit much or a bit confusing or a bit in depth, then it is a daunting subject, and the security stuff can be quite hard to get into. There's maths involved and algorithms, and it can seem pretty complex. I mean, lots of acronyms, PKCS, OEAP. I had to look up what RSA. I had to look up what everything meant. But RSA, particularly, it is just the initials of the names of the people who created the algorithm. And I'll tell you them afterwards. I wrote them down. What did I say here? Like what's padding? Why do we need padding? Why is there blocks? There's lots of things to do with the encryption stuff, which feels pretty daunting. But I would say that encryption in general and security, it happens a lot in layers. So, I don't know how the RSA key is. I don't know how it gets generated. I don't know how the AES algorithm works particularly. I'm sure I could go and learn, but you don't need to know. I don't need to know that. And you might not know about the different keys, AES or something like that, but you can understand how asymmetric encryption works or encryption works. You don't need to know about the actual key names, the actual algorithms. And, maybe you don't know about the actual, types of encryption that we can do, but encryption exists, hopefully, now. No one can say they don't now. So, there's layers to it, and you can start to peel them back and take your time. There's a lot to get into there, and it is hard to learn about it unless you've got some reason to. So yeah, if you don't get the opportunity, obviously it's going to be tricky. What else? Thanks for listening. Ollie asked me to do this talk like 2 or 3 weeks ago, and I was probably busy and just said, "Oh yeah, sure, fine. I don't know, okay." And then anyway, I've been away a lot, and so I was writing this today, and. That's me in Albania last week when I should have been writing this. Today would have been a lot less stressful if I hadn't been up there. But hey, we're here now. So thank you all very much for listening. Hopefully you got something. And yeah.